So selection sort is the next sorting algorithm that we will see. So first thing is, it sorts an array by repeatedly finding the minimum element, okay, from unsorted part and putting it to the beginning. Okay, interesting part. So it basically divides an array by two parts, a sorted part and unsorted part. It finds the minimum element from the unsorted part and put it to the beginning. Okay, let's see the visual representation. First algorithm. So we have to find the value in the list, minimum value in the list, swap it with the value in the current position, and repeat the process for all the elements until the entire array is sorted. Okay, fair enough. So let's see, we go with this array. So 8, 12, 5, 9, 2. Obviously, we can see this is not a sorted array. So the first step, we start with this index, the first index. We assume that this here, the whole array is unsorted. So what we will do, we'll actually try to sort the first position. So basically what we will do again, we will find the smallest element in all of this array. In this whole array, we'll find the smallest element and we'll put it to this position, the first position. Okay, so this min index will help us to find the minimum element and put it to the first position. So let's see. So what it will do, it will compare and will see that whether among these two, okay, 8 and 12 is smaller than 8. The answer is no. Then it will compare with 5. Is 5 smaller than 8? Yes. So it will swap 5 and 8. So you see the minimum now pointing, instead of swapping the values, the array minimum, I forgot the word, the variable, yes, the variable minimum is now pointing to the 5. So previously, if you remember, in case of bubble sort, what we did, we actually swapped two adjacent elements, but now we are not just swapping the elements, okay? We are actually swap once only. So we'll discuss it later more. So then again, you will compare these two. Among these two, is this the smallest one? Still 5 is the smallest one. So min will point to 5. Okay, so min is still pointing to 5. Let's go for the next one. So among these two, is this the smallest one? Yes, 2 is the smallest one. So now what will happen? Min will point to 2. So after the whole iteration is done, now we know the smallest element in this array is 2. So what we will do, we will swap 2 and 8. So you see what we have done, we have swapped this two position. Now, what is the first thing that we notice? That we still had to do the comparison just like the bubble sort algorithm, but the difference was in the bubble sort we had to do many swap. That means changing one value from one memory location to another memory location. But in this one we had to only do one swap, and each operation actually counts. Whenever we are doing a million calculation, each operation counts. Now again we will start, so this is the sorted part of our array. So again we will start with the 12 position. So initially 12 is the mean, and then again we will look that is 5 is the minimum now. Yes, 5 is the minimum. So we'll compare this two and we'll say 5 is the minimum. So we will change the value of mean to this 5. Okay, then we'll go for the next one. So we have updated the mean to 5. Now the mean is now pointing to 5. Then we'll compare 5 and 9. Still 5 is the minimum. We'll compare 5 and 8. Still 5 is the minimum. So after the whole comparisons are done, what we will do, we'll swap this 5 with 12. So swapping is done and this whole array is now sorted. And after that, as usual, we'll start again from 12. And from 12, we'll first initially point that 12 is the minimum. And then as we go compare, we will say 12 is not the minimum. Which one is the minimum? 8 is the minimum. So we will swap. And again, after doing so on, finally, we have this sorted array and we have, So we have this sorted array and we have unsorted array. So basically the advantage we did here is that the number of iteration was not less, but the number of swapping that we had to do is become much less, number one. And this is another example. Okay, you can go through it and practice on your own. Now, here is another question for you. So what is the output of selection sort after the second iteration given the following sequence of number? So you have a sequence of number. What will be the output after the second iteration? So the answer will be, okay, we have seen that this is our input, and answer will be, as you have said, that it will be D. Why it will be D? Let me explain. First of all, we know that in the selection sort, we find the smallest and put it to the front. So obviously that at first, as this is the second iteration, okay, that after the second iteration, that means two iteration is done. So the two smallest elements here is 2 and 4. So these two should be at the front. So here in only this one and this one, so this two is first out at the first look. Why? Because in this two, the smallest two are not at the front as per the selection sort algorithm. Now let's see which one is it. So 9 13 18, 9 13 18, 37 45, 45 37 63. Now here initially it was given 45 37 and 63. So this one and this one matches. Here what they did, they have swapped these two elements, but we know that these two elements will not be swapped until we reach at least the end of it, because the swapping is only done in selection sort when you you go up to there, okay, one by one. So it will be swapped in 1 2 3 4 5 6 7, seventh iteration. Now it's time to see the code. So the code for the selection sort is straightforward, same as the bubble sort. We start with a loop I up to the length of the array. We take a minimum index variable to keep track of the minimum index. Initially we assume I is the minimum index, and then for every comparison we do, okay, we keep track of the minimum index. So if we find a value that is smaller than the minimum, we update the value of minimum index. And in this way, after the whole for loop is done, okay, we actually swap it. So this is the step-by-step selection sort algorithms. Now if you don't understand this one, it's fine. This is the simplest code, actually almost look like a pseudo code. That's why I'm actually showing you the Python code, but you can watch it in C and C++. Okay. Now what is the time complexity? Again, the time complexity is order of n squared, as we have two nested loops. And what is the worst case scenario for selection sort? The worst case scenario is that whenever you are trying to sort it and the smallest elements, okay, we have to go through all of the array. There is no confusion, right? So the worst case will be that you are trying to find an minimum index and all the minimum index are in the last position. So did you get it what I said? That in this selection sort, your challenge is to find the smallest index, smallest element, and bring it to the top. So here, as you can see, that this part of the array is already sorted. Okay, there is only one element that is actually out of order. But if you apply the selection sort, what will happen? From this whole array, it will first find one, and then it will swap 1 and 2. So after the first iteration, it will look something like this: 1 3 4 5 2. So he just pushed 2 at the last, and then again in the second iteration, it will again bring 2 here, and it will bring 3 here. Okay, so it will look something like this. Let me update. So it will 1 2 4 5 3, and then in the next iteration, it will again swap this 3 and 4. So basically what we're doing, the problem is that because the last index was the smallest, every case what we are doing, we are taking a value, okay, and minimum value, pushing it to the last, and then again we are doing some comparison and so on. So this is one of the worst case of selection sort. So try this example on your own and you will get the idea why this is the worst case example.